Hello everyone. So welcome in the new video. Today we will measuring water quality with a TDS sensor and STM32. So here TDS means total dissolved solids. It's basically how much stuff is in your water. It's high TDS means dirtier water, and let's code it with STM32. So today we are going to see a real world problem. However, this is very useful when you combine this with IoT. But now our focus is on our STM32 board only. So I'm using one sensor which is connected with our STM32 board, and we are going to sense this value and we will display this on UART. Along with this, for time related thing, we are going to use real-time clock. So measuring water quality with STM32 is very challenging thing when especially if you don't know about STM32 hardware, because here three modules are involved. One is ADC, which is analog to digital converter. One is real-time clock, which is RTC, and third one is UART. It's a universal asynchronous receiver transmitter, which is useful for serial communication. So this will be the block diagram, right? This will be the connections. Sorry. So in connection, you can see only three pins are connected. Anyway, I'm going to see you the actual hardware. Okay, in the end of this video when we will going to demonstrate this. But for now, you just consider that three pins are connected. So basically, TDS sensor is having three output pins. One is for supply, one is for ground, and one is for analog signal. So here, TDS sensor will send some analog value, which we will going to read from our STM32 board. And based on analog value, we will convert this analog into equivalent TDS value, you can say, right? So these are the specifications, technical specifications. Okay, and we are going to use its UART to display this value in output. So let us start coding. So here I have created a new project. So let's give name TDS test STM32. So I have already selected the board. Okay, and basically this board is same Nucleo 144 board, which we have already seen in our all past videos, especially hardware related things. So let us first clear pin out. So as we know, first thing is we have to provide the crystal. So let us select RCC and crystal. Then second, we are going to use ADC, ADC0, IN0. So you can see this will enable this pin APA0. So you have to check in Nucleo 144 board on pin connectors where this P0 pin is located, and you have to connect your analog pin with this pin only, right? Because this pin, through this pin, it will convert analog into equivalent TDS value. So this is what ADC. I'm not going to change anything. In timer, let us enable RTC. So this we have already seen in our past video of STM32. So same thing we will do again in this video. We will generate 1 or 2 second delay using RTC only. So it will be not HL delay or inbuilt some random delay. We are going to use actual real-time clock to generate 1 second, 2 second, 3 second delay. Okay. And last is our connection. For connectivity, we are going to use UART3, because on UART3 we're going to send our data. And as you know that by default it will select this pin, but for onboard UART we have to select PD8 and PD9, right? So directly we can open our COM port on which our board is connected, and directly we can receive the data. Okay. So now again, baud rate is not, I'm not changing anything, it is same. So let us generate the code. So basically here we have to configure three different modules. One is ADC, one is UART, and one is RTC. Okay. So let us start with the code. So first of all, let us include few header file which we will use in our future part of next code. Okay. So now let us start with the reference voltage. So in ADC, what is reference voltage? So reference voltage is a voltage for which, let us say our reference voltage is, let us define first of all, then I will explain you. So I'm defining this reference voltage as 3.3 volt, right? So now what this 3.3 volt will means, the meaning of 3.3 volt. So whenever on this PA0, whenever on this PA0, 3.3 volt will be there, it will generate maximum reading. Now what is reading? So here you can see one term, I think here also only it is written. Let me search for you. Right, this is the resolution. You can see ADC resolution. ADC resolution is 12 bit. So what is 12 bit? So for more information about ADC, you can check my previous video. I will put this in my description. But for now, just for understanding, 12 bit means we have D0, to D12. Okay, D12. So for any input value, for any analog input on A0, it will represent with 12 0. So if the voltage at PA0 will be 0, so ADC will give all 0. Okay, and when you convert all 0 into equivalent decimal, it will be 0. But if your 3.3, if your reference voltage is 3.3, and if you will apply 3.3 over here, so 3.3 is your reference volt maximum. So it will write all 1 on these 10 pins. Okay, and writing all ones on 12 pin, it means around 4096, right? So this is the meaning of resolution. So if you have 12-bit ADC, so for each input value, it will generate 12 binary output digit, and then you can convert this binary into decimal, and you will have some numbers. So whenever we will going to read, means whenever we will read this ADC, it will give us this type of number: 256, 1024, 325, right? And we have to convert that number into voltage. So now let us say if I have this number 4096, and if I have to convert this into voltage, then our equation or our convert means what, how we can convert this number into voltage. So for that, simple, you have to multiply 4096 with your reference volt, which is 3.3. Okay, divide by your total resolution, means resolution is 12 bit. So for 12 bit is 2 raised to 12. You have to divide this by 4096 again. Okay, so now if your input voltage is 4096, so this is your ADC output. Okay, so if your ADC output is 4096, then put it over here. So when you, then this both will cancel and your output voltage will be 3.3. Same way, if your PA0 is 0, so this will make 0. If your PA3 is exactly half, right? So you will see your voltage will be half. So this is the equation how we can convert this ADC into equivalent voltage. Anyway, we will going to do this in our video, but for now, just remember what is V reference. So V reference is reference voltage, right? And then let us define the resolution. And our resolution is 4096 because we have 12-bit ADC, right? So now this both things we have defined. Now we have variables. So these variables are already defined over here. You can see ADC type, then RTC handler, and UART handler. Now some more variable that I am going to use in my future coding. So first is ADC value, right? Because we have to store this ADC value. So initially let us take 0, then voltage. Okay, so we have to convert this ADC value into voltage. So let us write 0 initially. Then we have another TDS value. Then we are going to use UART, right? So you have to also use UART buffer. So UART buffer, and we will take size of 50, length, right? So we will going to use this variable to store the string value. Okay, and then we have RTC as well, right? So in TDS test STM, let us open the driver. Okay, and here we will going to use some functions. Also, let us open ADC. Okay, so we will use these two functions. But for now, to declare two different structure of RTC, time and you can say date, we have to use time type def, right? So if you don't know about this, then please watch my previous video. I have explained in detail what is time type. But let me search if yes, this is. So this is actually type of structure, right? So to declare initial current time, because what we are going to do, we are going to display our temperature with interval of 2 seconds. So for that, I have to check or I have to save the current second. To save the current second, I have to use this type of structure, right? This part I have already explained you in my last video of RTC. And then again, I'm going to use another variable called last time. So current time and last time, when the difference between these two will be 1, we can say 1 second interval is there. Again, this is structure. So in current time, we have minutes, we have hour, we have seconds. So how to extract this, I will explain you in later part. And I have already discussed this in my RTC video, right? and finally you int 8 underscore t, our first run variable. So this is for first time. Okay, so first time we will do something, some logic based on this, and then we will load 0 in this variable, right? So now this declaration part is over. Now let us define our function. Okay, so first function is TDS, because our task is to read TDS value. So I'm just giving name read TDS sensor. Okay, so here only I'm going to read the value of TDS and return. Okay, so now first of all, how to start our ADC? So for that, let us check this. Right, so this is how you can start your ADC. So simply in read ADC, we are going to start our ADC. It's as simple as that, right? And our handler is HADC1. So we have to pass HADC1. So this is how you can start conversion, right? So it will start the ADC. It's like running, or you can say simply start this module, right? Now to convert, we have another function. So let us search it over here. So HLADC poll for conversion. So let us use this function. So I am showing you how to read this function because no need to remember. You can directly copy and paste it over here. So what I'm checking if ADC pole conversion is equal to HL OK. It means now conversion part is finished. We are waiting for the conversion, and when conversion is complete, the value or the output of this will become HAL OK. Okay, but now here some arguments are there, so we cannot write this argument as it is. Okay, so here only two arguments. One is a handler, so we know what is our handler. It's HADC1, and then timeout. Let us put some random number 100. Okay, so we will wait for this to become okay, and once this will become okay, we can say now our conversion is finished. Sorry, and as conversion is finished, we will simply save our value into ADC variable. Sorry, I have to use this side ADC value. And now how to get this? So now this will indicate that okay, ADC is finished now, but we have to read this value. Okay, so for that we have get value function, right? We have get value function, so you can search it simply at ADC get value. Okay, and we have to type its handler only, simple. Okay, so this is how you can get the value of current ADC. So again here, what will be the output? We have some 40962014, that type of value is there. Okay, so basically binary will convert it into decimal, and then the decimal value you will get in ADC value variable. So now you have to convert this into voltage. Okay, so for that we have this ADC value, okay, into V reference, which is our 3.3, okay, divide by our resolution, right? So where is that? Yes, ADC there. Yes, ADC resolution is 4096. So now this will simply convert ADC into equivalent voltage. Okay. So if your ADC is 4096, then output voltage will be 3.3. If your ADC is 2048, half, then output will be 1.65 watt or something, right? So this is how you will get the number. Okay. Now we have this TDS. We have to now save the TDS. Okay. So now we have the voltage, but now how we will going to save this in TDS variable, or you can say how we convert this voltage into TDS. So for that, one equation is there. This is our sensor, TDS meter sensor. So this is how we have this probe. We will insert this probe into water, right? And we are using this equation. So this is standard equation. So directly voltage will not convert into TDS directly, but we have to use this conversion, this formula, you can say. So 133 into 42 in 133.42 into voltage cube minus 255.86 into voltage square plus 857 into 30 or 39 into voltage. Okay, overall into 0.5 or divided by 2, you can say. So this will be the TDS value. Okay, so I'm just using this formula as it is. We also have a possible, option to convert this, or you consider temperature, right? But right now we are not considering this temperature. We are assuming that this will be only at room temperature, so temperature will not change. So that's why I'm not using any temperature sensor. But to make it industrial ready product, you have to consider temperature sensor as well, because as temperature increase or decrease, the TDS voltage this sensor will give different output, and you have to compensate that. You have to consider that temperature. So here in this code also it is mentioned, but now for now we are just considering that temperature will be room temperature, and it will not affect much on our actual output. So let us keep this as it is. Okay, and I'm going to use in TDS value. Okay, yes. So now this is done. Means we have the TDS value, and if TDS value is somehow negative, so what we will going to do? We will make it 0, because to prevent the negative value. Okay, right? And then finally we have to stop this. So whatever we have started, we have to stop it. Okay, so you have to write stop simply, and then you have to pass this handler. Okay, so this is how you can start it, you can stop it, and whatever value we have, we will simply return it. Okay, so this is what the TDS read TDS sensor function, right? Now again, after this conversion, we have the value, but now we have also have another module called real time clock. So for timing function, again I'm going to write another function, and this is check time. Okay, and here I'm passing second. Okay, so I'm going to pass seconds, and we will convert this second into equivalent delay, right? Equivalent delay means what? So what, when user pass 2 seconds, so it will sample this data at 2 second interval and send it. Then user will pass 5 seconds, it will sample TDS value at 5 second interval, right? So this is basically that delay. Okay, now again, if you know my how to use this get time or date, then you have to use two functions. If you have seen my previous video, if you don't know, then please watch my previous video. Okay, so we have two functions, get time and get date. Okay, and whenever you work on RTC, you have to use both the function one by one. If you only read time, or if you only get time, and if you miss this date, the RTC will never going to start, right? It will never start. So you have to follow this flow. First you have to write get time function, and then you have to write get date function. Okay, and here also three arguments are there. One is our handler, which is HRTC. Okay, second is the variable. Okay, so for date we have the for time we have the variable. If you remember, yes, this is the variable, but as we have to also read date, so I'm going to declare another variable called date. This is again structure. Okay, so date content day, month, all right. Same way time content second, minute, hour. Okay, and now last argument is format. So format is a binary format. So I will put both the video in description. One is for ADC, one is for RTC, if you don't know, right? Here we will store this get result into variable, different variable for different thing, right? For date we have date, for time we have time. Okay, and then we will simply check if this is the first run, then we will simply load current time into last time, because this will read the current time and it will load this value into current time variable, or you can say structure variable, right? And I'm just going to assign that current time into last time. Okay, first time we will do this, and then we will make this first turn is equal to 0, so this will not going to execute again. Okay, this is only one time execution, sorry, 0, and then we will return 1. So this is first time execution. So first run, we will save the time, allow read, Now here we will going to write our actual function when we have to check whether the difference of current time in previous last time is 2 seconds or not. So for that, I'm going to use another variable time different is equal to current time. Now this is structure. So we have to extract the value. So you can see we have our minute, second, fraction, second. Okay, all this. So I'm going to use second, right? So if current time minus last time dot second. Okay, so this will save into time different. And again, we have another issue. Let us say after 59 seconds, current time will be 0. So to compensate that negative part, okay, because 59 and then next time 0. So 0 minus 59, it will be minus 59. So to you know handle this type of thing, I'm just writing very small function. If time difference is negative, so simply add 60 in time. Okay. So if my time is 0, so it will make it 60 and the difference will be 1. Okay, so this is just to manage that portion, that moment when your second will increase from 0 to 60. So from 59 to 0, not 60, right? So this is what. And now finally we have the time difference. So simply we can check if my time difference is greater than or equal to my seconds argument. So let us say user type 2 seconds. So if the difference is greater than or equal to 2 seconds, then simply return 1. Okay, otherwise return 0. But here we have to do one more thing. We have to load this current time into last time. Okay, so for simplicity, let us say user passed 5 seconds. So what this will do is simply get the time, get the date. It will continuously check the difference. When the difference will be 5, so in the fifth second, it will return 1. It will load last time with current time and it will return 1. So this function executes, this function return 1, and user can get the idea. Okay, now 5 seconds is done. So now we can do next operation. So like whatever we want to send, we can send it. Okay, so now this is what two function we have defined. And now let us start with our core program. So in main, let us write one message. So this will be initial message display on our UART TDS sensor start. Okay, and send it on UART. So for that we have transmit. So we have used this function so many times, I'm not going to explain you that again, but you have to remember again here 3 arguments. First is a handler, so our UART3, oh sorry, my numlock is not on. Okay, so first is a handler, second is typecasting of our function variable, length of the message, and finally timeout. Okay, so after execution of this line, it will display this message on UART. So now this is just an indication, send startup message via UART. And in main loop, okay, we have to check if our function check time. So I'm just copying this check time. So if check time in argument, let us pass 2 seconds. Okay, so after 2 seconds, I want to display the value. So if check time is equal to, whenever this will become true, it will execute this part. Okay, so whenever this conversion will complete, and when time is when 2 seconds will complete, so exactly at second it will execute this, and just read this TDS value, read TDS sensor. Okay, so at second we will have the value, right? And then we can send this value on UART simply, okay? And this will complete our required functionality. So I'm just writing this code. Meanwhile, let us see this circuit. Now see this. So this is our Nucleo 144 board. These three connections, power supply, ground. This is our analog. So analog is connected with this board. You can see this is it's the analog pin plus 3.3 ground, and this is the sensor. So I'm going to put this in water, right? And this is the overall setup you can see. And now I have to generate the hex file also, right? So I'm just debugging, releasing the target. It will simply generate hex file for me. So again, this is the setup. And now we are going to load our program on our board. So you can see. So I'm simply loading the program. This is the release hex file. And this is the real terminal. So we have, you can see the UART part over here. Now let me reset this. This is the, you can see TDS sensor. And now here you can see ADC value, its equivalent voltage, and its TDS. So again, this is based on this water. Okay, we are not considering temperature compensation, right? And also I have modified some of the part of my code. So here you can see after reading the value, again we are just converting this whole conversion. Again we are reading this voltage TDS, and then we are displaying this. Okay, so this is what for today's video. If you want more precise value, you can see some variation is still there, but if you want more precise value, then what you can do, you can simply make average. So within 30 seconds or within each 1 second, let us read this sensor 30 times and then average it. So it will not give this type of fluctuated output. Right now you can see some fluctuations is there, but anyway I will put that code also in description, so you can directly use that code as it is for your actual project. So this is what for today's video. If you like my work, then please like my YouTube video, subscribe my channel, share it with your friends. Till then, bye bye. Thank you. Thanks a lot.